So at a high level, let's talk about the UDM. Some of the major concepts that we have going here are semantics. This is about words, bringing meaning to words. It's a subset of linguistics. We have wayfinding, which is how you go about finding what you need, kind of like you're into a new city and you need to find McDonald's, or you need to find a hotel to sleep in, what have you. The way you find that is well established in history of the way your brain is wired. Truth seeking, we'll go into these here in a little bit. Representations, inferences, and viewpoints. Okay, now to explain those, we need to kind of dig into them a little bit. So first of all, we need to point out that in the database, we're really talking about containers for data, not data itself. So if you look at a table or a column or a field or what have you, all that's really there is the structure or the container to hold that data. It's not the data itself. If we have a field that holds 5 alphanumeric, that's really all we know about it. But if the data is 55122, we may be able to, infer from that that it's a zip code, but we don't really know that unless we have a customer's populated database. So for the most part, a data dictionary is just talking about containers and what is allowed in there and what is intended to be in there, but not the actual data. So I think that's an important distinction that's going to come to play here, because as the UDM extends into a variety of variant products, we're going to move more from containers to the actual client data and bringing meaning to their data literally, as opposed to just what is intended to be in there from the containerization of the schema in the database. Now let's talk about what we just looked at. We looked at different perspectives. We had the conceptual, we had the logical, and we had the physical. So let's talk about that a little bit, because it's a little, spell that right. It's a little abstracted, but these are all representations of reality. There are only 2 realities that exist, and that is going to be the database itself, the physical database, and the real world of their business, of what they're running. But those really, as concrete as those sound, they're really useless, because to get at them and to understand them, we need to represent them somehow by something that is a metaphor or a representation of them. So the database itself stores data in a much different way than we'd ever want to talk about. If we're talking about the way that the alignment of the magnetic particles on the disk are orchestrated to represent a number, for example, it has little to do with a relational database or anything that has to do with business. It's more about physics of electromagnetism, and so that doesn't really help us any. There is no such thing as a physical relational database. What we really have is a schema, a bunch of containers that are represented by a database catalog, which is an abstraction of many layers all the way down to magnetic bits of flux on the magnetic platters. So what we really end up with is a representation that's as close to reality as we can get, and we call that, just for purposes of convenience, the database catalog or the schema. But as you know, when you pull a schema out, it's really just pulling out a view of a bunch of objects that are being assembled for purposes of showing you what the schema is, but it's not really physically in there. So the database catalog is very close to what we call our physical representation up here. However, it's different, because this is literally, we can take this as reality just for purposes of discussion in the UDM, but to have this be useful, we need to have another representation done of it where we actually flesh out the details. So for example, there may be no description, which there is not in Lily's case, of what the tables do. There's a metadata column in there, or a field in there where you can describe what a table does, but it's not populated. So we need to go in there and use inference, or we need to use our own street knowledge or what have you to describe what that table is, and extend what's in the database catalog into a physical representation that is useful. So that's kind of where this comes from, the physical representation. Likewise, the real world, for it to be useful, we have to have some metaphors. We can't just literally, go get a customer, because a customer is not a record. It's a physical customer that exists someplace. We can't go package them up somehow and take pictures of them. We need to actually represent that through some means of conveyance of information, and that is the conceptualization of it up here. And in this case, it's going to be just natural English. We're going to describe it. So it'll be a customer, and we can use English to describe what that customer is. And a purchase order is a document, and that might be as close as we get to something physical. We could actually look at the piece of paper that they use for purchase orders, particularly if it's the old manual system, or an inventory tag, something like that, that was pre-computer era, is actually quite useful. However, that then has to become something that we can manipulate and use. So we need to encapsulate that into some type of English grammar sentence structure, and that's this conceptualization layer here. The truly useful one is going to be the logical layer, and that's where we build a bridge between that conceptualization and this physicality that is truly useful, that helps us interpret and bridge how the real world is implemented into the database, so that we can traverse back and forth and have things not only mapped and traversable, but completely traceable and exclusively mapped, such that there is a path up and down and left and right that is not leaving you with a dangling thread that doesn't go anywhere, or some ambiguity. So that's the real challenge, and that's that logical layer is the magic that's going to do all that for us. So it's interesting, as we try to get away from these perspectives, these kind of abstract things, and get into the real world, we end up right back where we started from, because in order to get that, we end up having to have perspectives or representations of the real world, just so we can understand it enough to calibrate our own representations up here back to the real world. So it gets to be a little bit of a word salad there, and a logical go around, but that's kind of the reality of it. So it really comes down to the principle of quantum mechanics, where the mere act of observing something changes the thing that you are observing, and you can't ever get away from that. So the observer becomes an inextricable part of what is being observed. And I think it's important just to go ahead and embrace that and make that part of what we're trying to do here, and not try to make this something that breaks the laws of physics, where we're looking for a reality out there that is absolute, concrete, definable, and that we can hang our hat on, because that's what everybody kind of wants to believe in. And that's just not the way the world works. The reality is as much about you as it is about anything else, and it's very pliable and morphable, if you will, depending on the observer. So the whole point of the UDM is to embrace that fully and say, all right, if we're going to do that, let's not skirt the issue. Let's go ahead and bring all the dynamics that are involved in that and use those to our advantage. So now we need to bring in some additional concepts of who's the audience, who is the observer in this case, what is their experience? Are they a novice? How do you spell experience? Are they a seasoned professional? Are they just an observer who needs to be just a casual learner? What have you? What's the subject being explored? We may be talking about purchasing, but are we interested in costing? Are we interested in distribution? Are we interested in inventory management? Different subjects within that particular business process. What's our learning modality? Are we someone who learns visually? Are we someone who likes to be coached? Someone who likes to be mentored? We'd rather have something that's hands-on, something that's book learning, step-by-step, different ways of learning. The proclivity, which is kind of my favorite, but it's really, how you relate to the world. Are you someone who wants something very buttoned down, prim and proper, and all the I's dotted and T's crossed? And if I say there's going to be 5 points, there's going to be 5 points, and not 4.5 or 5 or 6. That's different styles for different folks. Someone who is on the shop floor is really not going to connect with a CPA discussing how inventory is managed in visual. But similarly, someone who's just in there just kind of talking rough cut and using kind of street slang is not going to go very far with a CFO who's trying to understand the system that's going to run his $100 million company. So that proclivity is a very important piece of this. And that's really the binding, the chemistry that's going to work between the audience and the content that we're trying to bring meaning to. All right. And then we've talked about wayfinding, which is also very personal, but it's about, do you meander through data? Do you seek it, as in you're honing in on it? Or do you, I can't remember the third one, quite frankly, but we'll come to that when we get there. All right. So a lot of this becomes complex, but the interesting thing is really it's all about Occam's razor. The simplest answer sometimes is the most simple and direct answer. And that is what this is really going to be about. But in order to get there, we sometimes have to go through the looking glass, and that's what we're going to go do next. Okay, let's look at a concept of where being inaccurate and rounding the corners is essential to communicating something accurately and faithfully. Let's take a look at how you would sell visual manufacturing. First of all, it was sold originally as the only ERP system that is Windows-based, and that was a big deal because everything was text-based up to that point and rather kind of cryptic to look at. So if you wanted to cut a purchase order, I wish I had visual right here in front of me, but I'm going to have to draw little pictures here. But as you know, the purchase order screen literally looks like a purchase order, where the top is the header and has the lines going down like here, and then you just explain to someone how you just put the vendor up there, and then you go down and start putting in, I want to have 100 pieces of this particular part number, and the price pops up because it's for that vendor has already been established, and so on. And then you can say up here in the header, I want this to ship on March 15th, 2016. For all these lines, and bam, you save it, puts a PO number in there, the next available one, and you got yourself a purchase order. Just that slick. Then you come back and say, all right, now what's cool is, let's say that I have my second line down here is for some other part, and then I have a third line for 150 pieces of yet another part. They're all going to ship on 3/15 except for the second line. So in here I can say this one's going to ship on 3/20/16. The other lines I leave blank in terms of the ship date, and it's going to inherit this one down and fill those in automatically, so I don't have to put those dates in over and over again. So the concept of inheritance is introduced, which people at the time were impressed, because that was something that it may seem simple, but just wasn't available in commercial ERP systems that much. Then you could go in there and say, okay, on this line table, there's all sorts of columns in there that you can rename, you can rearrange them, you can change the width, and you can hide them. So if you have something out here for like wholesale cost, you can say, well, I don't really need that one, you can hide it. Or if you call that something different, like distribution cost or something, then you could rename that, and that would show up for you. So very configurable, very flexible. Then another thing that you could show is, as time goes on, this may be release 1.0 of the software, then 2.0 came out, and we introduced something like value-added taxes, so that when you have sales tax on here, if you're configured for the European Union, it would change to value-added tax and have all the tracking of moving around of value added throughout the distribution network, and that's how tax is added on. So there's different fields, different functionality for that of course ties into different masters and so on, a whole bunch of stuff that goes on behind the scenes to make that work. But it is something that they involved into. So when you start off learning visual, it's just sales tax, but then to say, okay, now in 2.0, we've introduced a value-added tax, which just takes the sales tax and makes it into an exclusive or type thing, where if you don't have sales tax, then you have value-added tax. And then they layered on additional features in terms of the reporting and traceability and trackability of that particular feature. So a lot of the internationalization was layered on, over the various major releases of visual. So that made it fairly easy to understand. Then, as they became more international, you want to rename things. So we may have up here, the title, Purchase Order ID. Well, in Korean or different languages, it's not, of course, it's going to be something different. So you're able to go in here and have substitution strings where you say, for this particular field up here, we want to call it this. And there's like 60 some different languages available, and those are also customizable. Then on top of that, you can use Object Nationalizer, which allows you to grab these objects and rearrange them on the layout independent of the executable. So when the executable fires up, it says, okay, the coordinates for this particular field have been substituted in a text add-on file that goes right with the executable. So as it's drawing this, it says, oh, I don't want it there. I want to actually put it over here. And I don't want to call it purchase order ID. I want to call it the so-and-so foreign language equivalent of that. Or I may want to hide that or resize it or something. And so therefore it paints this differently based on that internationalization text file. Okay, so that's a very nice feature that sells well when you're going through the process of competing with traditional text-based ERP systems. Okay, now what just happened there is I went through several techniques of center periphery calibrate. And what's interesting is this works well in the selling process, but somehow it doesn't work so well when we go to document something or provide technical information on a technical system. Somehow we go back and say, all right, the proper way to do this is to start at the top and work our way down and make sure that we don't leave anything out and make sure we give the whole picture. So what's really going on here is we don't have a purchase order entry screen. We have a APS, an Advanced Planning and Scheduling module that plans demand and supply planning for international customers or international ERP. So, and then what you end up with is a completely configurable layout, a completely configurable field titles. You have something that is language neutral. You have something that has regionality to it. And you have features that are exclusively OR to one another. And you have a layering of complexity. So what you kind of end up with is an abstracted system that you really can't explain or teach to anybody because it says nothing, it does nothing, and it can't be documented, and it can't be used as it comes out of the box because it's so configurable and so easy to use and so intuitive. So if I were to explain this in that manner, I would have to first start out talking about how we have this thing that is a document that has a header and has lines, but the header really can't be defined what that header is, nor can we apply any terminology to it because the terminology is configurable and customizable. And we really can't talk about the line because in reality, there's about 120 columns here. So we can't talk about the line without talking about the categories and the abstraction of all those 120 columns and how they interplay with one another. So what you end up with is something that is very difficult to teach and show if you're trying to grasp the whole complexity of the way the software was written. But if you do it where you're focused on what is most important, just the gut reaction, and then start building out from that and calibrating it back, it becomes really a simple way to learn a complex system. And that's how I learned it. I can't imagine walking into Visual 7.1 and learning it from the ground up and with the expectation that you're going to fully understand all that just even the purchase order entry screen could do, much less, you know, the entire package of software. It would be just overwhelming to understand what the core is because everything is so distracting and so abstracted. Everything that you think is something you can hang your hat on becomes a variable. You can't even identify a field or even point to something because it's configurable. And that's kind of the misnomer, I guess, of the object-oriented world is that everything becomes so abstract and so obscure in the quest to make something usable and friendly and intuitive. It becomes just the opposite of that. All right. So we have different techniques of doing that. And for me, it became kind of this evolutionary thing where you look at 1.0 version, then 2.0, and you kind of learn it in layers. And that naturally works because what's going to be in 1.0 is whatever sells the best. They're not going to put in value-added tax in 1.0 when they don't even have a basic purchase order document. But if you're going to sell an ERP system, you better have the fundamentals. Like I can cut a purchase order, I can put a custom order in, I can build a work order, and I can add parts. That's what counts at 1.0. And all you need is like cost, quantity, delivery date, things like that. And then with 2.0, you can start sprinkling in a little more feature, richness to make it work. But then not until you get to 3.0 or 4.0 do you start really going after some of the esoteric features that are sprinkled on top of all that. But that becomes this evolutionary layering so that when you look at this, you can kind of see evolution kind of as you look at columns, particularly in the database, because they are literally laid out in chronological evolutionary order. So it makes it quite easy to understand it, at least from my perspective. So that's my observer bias there. But it's also important to not get hung up on like, well, you put the date up here for when you want to ship, but unless you want to have one line different, then you got to put it down here. But then if the other lines don't ship different, you can either put that date here and here or not put it there. But either if you get into all that while you're trying to explain how the PO works, you've long lost people's interest in the fact that this PO is really easy to use because you've got so hung up on those details. So I think it's more important to say, hey, you just stick the date in here and you do all this, and then maybe at the second discussion, second pass at it, you say, oh, by the way, we want to have that particular line shipped differently. Now, how do we do that? Bang. Then you talk about this concept of inheritance because now there's a point to it and it's of interest. So that's exactly how Dick Lilly sold this system. And to do that, it's really more about what you don't talk about than what you do talk about. So if someone would say, well, how does this hook into accounts payable? And he would describe it and show how it hooks in and vouchers and that's where the cost comes from and the actual costing works that way. And they say, well, can you show it to me? And he'd say, no. And people would just be astounded by that. He literally meant no. He said, if you want to see my payables module, then don't buy my software because you're going to be very disappointed. But you have to trust me that it's a payable system, and payables is not very glamorous. It gets the job done, but you're not going to much like it. But if you're buying my software for that, then you're in the wrong place. That's because he was back here, But when he gets up to version 6 of Visual, then the financials got rewritten into Global Financials, which is a world-class financial software, which would be the showcase at that point to show off. Therefore, the classic financials kind of never really got shown in a sales demo, at least from Dick Lilly himself, because it was something that was just there to make the system work, but certainly not a selling point, and he didn't want that to become a distraction. So you end up hiding or intentionally and assertively not showing something and not explaining something to make the overall explanation clear and focused. All right, and that's what's really important also in the UDM, is that we go about this from different viewpoints and different perspectives, and we don't try to do everything to everyone at all the same time. So this is kind of this tapestry of representations to make this all come clear. And believe it or not, that is actually a simpler and more direct way of communicating meaning than trying to do it top down. Somehow, like, again, there's some reality out there in outer space that we have to just tap into, explain it, and then we all have that one thing to calibrate to, and that's just not the way reality is. We have the sentence structure up there of natural language. We use purchase orders to procure parts for inventory. Again, that is the conceptual perspective. The conceptual. So that's about as close as we can get to the real world by just using plain old English that is structured, but yet natural English, natural language, informality. And then to get the logical, we break this down like we were just talking about, where the purchase order comes down to a document, specifically a purchase order. So the logical representation would be an entity called purchase order. And the entity category in this case is documents. Procure part, and then the parts here is a master. So that's the kind of data we're talking about. But the entity in this case is a part. And let's just leave it at that, keep it that simple. So this is the logical. We just have two entities. Now we bring it down to the physical layer, and these entities break down much more. So the purchase order becomes a purchase order header and a purchase order line with a one-to-many M relationship. And then the PO line actually breaks down more into a delivery schedule. So each one of those lines has multiple lines down here, potentially multiple lines for the delivery schedule. So this is a 1 to M. This is optional, whereas this is mandatory. So that's the cardinality going on there. And then there's a bunch of other stuff. For example, this is all that's really required for building the proper relational denormalized structure. But we also have, just for performance reasons and for technology reasons, we've broken off the PO header binary data into a separate table. And that's brought over here. And that's a 1-to-1 as an optional. In this case, so if we have a picture or a long description or something that requires a blob data type, that goes into a separate table so it doesn't clutter up the main data table. And the same thing here for the PO line binary, like that. So this structure here is what is all encapsulated into that one entity of purchase order. Likewise over here for the part, you'd think it's just a simple table for parts. Well, there's actually probably well over a dozen, maybe even 24 tables involved, because you have the cost structure, the pricing for it, you have seasonality, you've got substitute parts, it goes on and on and on. So it's a very complex structure actually for parts that blows out into all these different ideas. But the concept though is still that we just have one entity called part. So that is the different perspectives or the different layers of perspective that we put in the data dictionary.